my mic on, sorry. We'll give a second for it to, there we go. Okay. I'm not used to being recorded for video. Normally people say be quiet and not talk louder. So anyway, again, I'm Jeremy Fischer. I am the manager for Jetstream Cloud. We're going to talk today a little bit about what Jetstream is, how it might benefit your research, and how you can go about using it. So without further ado, we will jump in. So a little bit about where we come from. So I'm going to give you some background before we talk about Jetstream itself. Traditionally, funding from the NSF for HPC has been in flops. So Blue Waters and now Frontera, Stampede and Stampede 2, Comet, and now Expanse is coming. And then there was kind of a shift to look at experimental clouds. So we saw Cloud Lab and Chameleon get funded, and they've both been extended as well. And then we saw a shift to production clouds. So we saw Bridges, and Bridges just got funded for Bridges 2 and Jetstream, and hopefully funded for Jetstream 2. We're working on that now. And to talk a little bit about the need. So Exceed, how many people are familiar with Exceed? Oh, good. Man, that's, most audiences I go to, I get like one hand. It's fantastic to have an audience familiar with Exceed. So Exceed did a survey a number of years ago on why people are or are not using national cyber infrastructure. And really what it comes down to, there's a lot of words on the page, but everybody says they're resource constrained. But there are a lot of reasons why they weren't using national cyber infrastructure. Part of it is they didn't think they really needed it. It was too much for their needs. It was hard to, there was a high barrier to entry. Various reasons why they couldn't or didn't need the national cyber infrastructure despite being resource constrained. So one of our goals from the NSF was to identify these communities and help bring them into the national cyber infrastructure. This is actually something I hear. I spend most of my time traveling to talk about Jetstream, to engage researchers, to get them online and using national cyber infrastructure, whether it's Jetstream or something else. And it's amazing how many places I hear this. I really don't have research needs. I don't need the national cyber infrastructure. And the next thing that inevitably happens is we walk through their lab, going to a conference room or whatever, and I see a PC sitting on a desk with a sticky note on the monitor that says, "Do not touch for 2 months." And so of course, the next question is going to be, what's that doing? Oh, it's just doing some number crunching. It's nothing big, but don't touch for 2 months. Well, yeah, that's about how long it takes to run this. Oh, we need to talk. And at that point, I've got them. But that demonstrates the perception of people thinking that their problem is just too small to need national cyber infrastructure. So it's part of my job to help them show why their research is important and it deserves a place on national CI. This is also one of my favorite things. This was actually plucked from Twitter. And this is the author with her laptop going down the road, and the reason is her R calculations were not done. She wanted to know if she could use the HOV lane with this. This actually makes the example perfectly. This user is a perfect example for national CI, and especially Jetstream for doing interactive R calculations. So this usually makes the case for me. And I show people this and like, oh, I don't have to use my laptop for everything. Exactly. So why do we exist? So we are the National Science Foundation's first production cloud facility. Our mission given to us was to focus on broad accessibility, getting as many people to the table as possible, trying to get the people that are currently underserved or not served at all, make it easy for them to get online, give them something that they can use like a library of virtual machines, on-demand and interactive, which is not something you typically find in the HPC world in the national CI. And then what we like to call programmable cyber infrastructure. Within reason, if you have a strange need, we can probably help you try to create it. And that falls into a lot of different things, whether it's security testing. We have some people doing penetration testing, which is not something typically easy to do on a local network and not something your local security network guys want you doing. Usually get nasty grams for that sort of thing. But we help make an environment where you can create what you need to get your work done. So the who. So Jetstream is modest size VMs, 1 to 44 cores. We focus at people that are initial users, low-level users or interactive users, software creators and researchers that basically need a lot of control. So you want root, you got root. Science gateway creators. Are people in here familiar with the concept of a science gateway? Yes. That's something else that typically doesn't happen during these talks. Science gateway creators love systems like Jetstream and other cloud systems. But my personal favorite is also STEM educators. So we focused a lot on training the next generation of researchers as well. So we like to engage the people that are, whether they're professors in an academic setting or they're people doing workshops and training other professionals. We like to give them a place where they can have a consistent environment. You don't have to worry about, everybody installing the stuff on their laptop isn't going to work. If you're a Mac user and you've ever had to install Python for a workshop, you know that there's even odds that about half the class is going to fail it. It's just not going to install for various reasons. So we like to give a place where people can have a uniform environment. All the students can come in, they can use the system via the web server or with a web interface and not have to worry about any other tools. So what Jetstream isn't? We're not traditional HPC. That should be pretty obvious. We're a cloud system. There's no shared file system. So people that are HPC users that might be coming to us look for that giant Lustre file system. You're not going to find it. It's time to think cloudy. So you think in small, bite-sized pieces that you're going to use locally. No high-end fabric. So if your timings are so critical that you absolutely need InfiniBand and the highest performance and lowest latency, it might not be the right place. There are not GPUs yet. I say yet. We have purchased GPUs. They are in testing and benchmarking right now on the IU Cloud. We hope to have them released to limited testing very, very soon. I do not have a date because we're working on all the benchmarking for that presently. And then lastly, I like to say we're not Amazon, Azure, or Google for the obvious reasons. We do a lot of the same services. We offer a subset of what they offer. But at the same time, we don't have their budgets or their staff. But what we like to think is, since we are run by people that support researchers, we know how to support researchers. So we speak the same language. We do have doctorates in various fields of study on staff, but we like to think we're good at supporting researchers. So again, HPC versus cloud. So people that are coming to us from HPC are often, oh, I don't have to wait in a queue, I don't have to wait to get a VM, I can just get it now? Yeah, absolutely. You are your own admin, you have root. And there's an asterisk with that. Here there be dragons. It's almost inevitable that people that haven't had root before will end up stepping on themselves. My favorite is actually I was over somebody's shoulder that was using a VM for the first time, and they were semi-Unix literate, but they typed rm-rf/ as root. And of course, interpreter not found. And they're like, well, how do I undo that? You don't. Let's just delete it and start over. So it's one of those things. There are caveats. Having root is fantastic. I'm a sysadmin by training. I love having full control, and you can shoot yourself in the foot so gleefully and so fast that it's fantastic. The next thing, you can really have almost any Linux software you want, and again, still dragons. And the reason I talk about Linux software versus Windows is somebody will inevitably ask, do you support Windows VMs? And after I stop laughing, I say, no, I'm sorry, we don't. And there's a couple reasons for that. One is mostly a legal reason. The way Microsoft wanted to do licensing was going to be cost prohibitive to us, and it was going to require us to map off a section of the cluster that could only ever run Windows and nothing else. So it was not in our best interest and not in our users' interest for the small number of users that asked about Windows. That said, in the Linux world, if you have it and it will run on Linux, you can probably run it on Jetstream, and you have full control to install it. If you have something that's licensed and you want to bring it, as long as it's not breaching your license, have a way. So we give you that control. Sorry, web users. Yikes. Okay. I'm also not used to wearing a mic, so I just knocked the mic off for the people playing at home. And then the other thing is users like no scheduled downtimes. So we don't schedule downtimes. When we do upgrades, we drain the hypervisors and move everybody to somewhere else. Most people have no idea that it's happening. We upgraded the IU cluster recently over a span of 3 days, and with the exception, unfortunately, of some Unidata colleagues, nobody had any idea it was happening. And the Unidata colleagues were our fault. So, but for the most part, nobody notices when we do maintenance, and that's a fantastic thing. So we don't have any scheduled downtimes for the most part, network aside. The other thing is, if people have questions as I go along, raise your hand, jump in, interrupt me. I don't want to miss anybody's questions if you have them. So the way of the cloud. So I'm of an age where I remember when there were a lot of players in the HPC and computing market, when Digital and Sun and HP was still making sort of hardware. And you expected that the hardware was going to be really expensive and it was going to last, you know, for the entire life cycle of the project, and you weren't going to worry about it. You expected the hardware was just going to live and it was going to be bulletproof. Today it's a little different. The hardware is pretty much throwaway. If something happens to it, we just throw in another node and move on. We don't really care about the hardware. We expect the software to actually be the bulletproof part of the stack. But my favorite part about the cloudy way is this. It's thinking about VMs as cattle, not pets. So Mike Lowe, who is our system architect for Jetstream, basically brought us this concept that, you know, you care about your pets. You name them, you take care of them, you have them for a long time. If anything happens, you're sad. With a VM, you want to think about it as part of the herd. So you create your workflow, you save your workflow into an image, and you can recreate it again and again and again. And if something happens to one, you might lose a little bit of time, but you can just keep going and just launch another one and go again. And so that's the way we like to think about the cloud environment and how we encourage our users to think about it. So to give a little bit of an overview of the Jetstream systems, there are 2 clouds. There's an IU cloud in Bloomington, Indiana. There's a TAC cloud in Austin, Texas. And then there's the development cloud, which sits in Arizona, which is for our internal use. We're all connected through Internet 2 with the ExceedNet backup. The 2 clouds are identical. There's really nothing different about them other than the geographic location. So to look at how one uses Jetstream. So the bottom is a pretty accurate representation of what Jetstream racks look like, with the exception we've added another rack for GPU nodes at IU. Sitting on top of it, we have OpenStack running as sort of our cloud operating system. It's backed by Ceph storage. This will not be on the test. And then we have how people actually access it. So sitting on top of all of that are a bunch of services that Exceed uses for us to access Jetstream. So we use Globus Auth to actually authenticate Atmosphere users. That talks to the Exceed accounting system. It talks to a bunch of Atmosphere services. And then we access OpenStack via the web app. 90% of our users come in through the web interface. The other 10% of users come in directly through OpenStack. So they come in through the OpenStack API, which is right here. So that's 10% of the users. The interesting thing about it is the usage between the two is 50-50. So the API users are our more intense users. They're more of our power users. They're doing bigger things typically. Some examples of that, we have some virtual clusters going on. To use Unidata as our example, they have nightly weather data processing that comes in, and they do a lot of usage on Jetstream. They're solely API users, so they come in, they have everything running via the API interface. Again, whereas most of our interactive users come in through the web interface. And there's no wrong answer, it's whatever fits your workflow. So to give a kind of look at the web interface, since this is where most of our users come in, this is Atmosphere. Atmosphere was developed by iPlant originally at University of Arizona, which is now Cyverse. They developed an interface that was intended to be easy to use, self-contained. You can do everything from the web interface if you choose to. You can use SSH as well, or XVNC if you choose to as well. So this gives you a nice basic dashboard when you come in. The main options of launching instances, getting help, changing your settings. You can see your Exceed allocations and your usage. You can see what you have in use. If you could scroll down and this weren't a PowerPoint, you could see the resources you have in use like CPU and RAM and disk space and such, and then you can see a history of what's going on. So we like to put everything here on the dashboard to give you a quick look at what you're doing and how you're using Jetstream. Then a quick look at the image library. This is an old image. Obviously, you can tell by the CentOS 7.2. But this is what it looks like when you come into the image library. You can see what we have. We have featured images, which are ones that the Jetstream staff maintains. And then as you scroll down, there are community images that are typically domain science images that other people have contributed and made available for everybody. So they can be anything and everything. We have a lot of bioinformaticians, so there are a lot of bioinformatics images. We have a lot of earth science folks, so there are a lot of earth science images now. But it's a little range of everything. But the upside is you can either launch something we bring you, or you can take what we bring you and then build your own. To give a little bit of a breakdown, this is looking at the users of Jetstream. Now, this is not all of the fields of science. Last check, and I think it's on the last slide, there were something like 72 fields of science. But we went in and did kind of a spot look at the biggest classes of users on Jetstream. And what we found is that bio folks are our biggest users on Jetstream by far. Part of that is they typically have long run times. They want to run more than most HPC will let them run. I think most HPC is typically 3 days to a week. You might find longer run queues, but a lot of bioinformaticians are, I need one core, but I need it for a month. We give them that option. So we're comparing what Jetstream has been allocated versus what Exceed has been allocated using the numbers from XDMod. And you can kind of see a look at who's using Jetstream. Earth sciences is actually one of our biggest growth areas, as I noted before. Okay, so it's self-identifying as part of it. So these are things that Exceed has said as their parent sciences, and that the PIs actually identify with when they get their allocation. If I recall correctly, this is everything, not just rocks. This is including rocks. Yes. Yes. Atmospheric, everything, yeah. Yeah. Absolutely. It's not something I thought about, but I can definitely see the point. But this is self-identified by the PIs, but it also includes a whole range of Earth-related sciences, I guess is the better way to put it, including atmospheric and water, rocks. I do. I don't have it readily available. I would have to do a little number crunching on it, but it's all available to me. Yeah, let me get your information after, and I'd be happy to send that along. So another thing that Jetstream does is we talk to the folks at MATLAB, MathWorks, and since IU and TAC both pay for ridiculous site licenses from MATLAB, they said, sure, you can make it available to Jetstream users. So if you have a need for MATLAB in your work, whether it's interactive or in batch processing, you can use MATLAB on Jetstream without using a license. You use our license for it, so you don't have to bring one. We have a lot of folks that are making use of this. Apparently it's more popular than we expected. It's a nice feature to have. And then what we like to call not just the usual suspects. So a lot of times, and I joke that if you give a cluster to a high energy physicist, if you give them 1,000 cores, at the end of an hour they will be ready for 1,001 cores. Molecular chemists are the same way. They're really, really good at using HPC. They've been using it for a long time. They know how to use it. They know how to exploit it. They know how to fill a system. What I like is that we're seeing not just the usual suspects. We're seeing a different group of people. We're seeing folks that are in financial analysis and economics. We have a stream of FDIC and Fed users that are using us now for some very interesting projects. Political science is one of the fun ones. There's one on there now who is getting ready to really ramp up that is doing Twitter sentiment analysis. And you can only imagine in this day and age the gold mine they're getting. So it's a really interesting thing. Also, we have one that's a bot detector that's kind of doing some interesting things. But humanities and text analysis. So folks that are not typically seen as HPC users, as folks that are high-end users of computing resources, are starting to come in and realize how much they can get done using a higher-end system than their laptop. Network analysis, security analysis. Computer science is an obvious fit for us. One of the more interesting ones was a student that just finished his PhD doing satellite data analysis, and he was using near real-time imagery coming from Planet Labs and Google, and showing erosion and land shift and things like that. It was very interesting. So it's not something that we really thought of when we were doing Jetstream, but it's ways that people have found to use it to their benefit. So again, education. So this is something that I hit on briefly at the beginning. But one of the things that we really like is training the next generation of researchers. And we've seen Jetstream used in a bunch of different college courses. We started at IU because they were close to home. It was easy to use them as a guinea pig. But now we have courses all over the country using it. Bioinformatics has, again, been a very big concentration. Computer science has also been informatics in every kind of form. Business intelligence has actually been one of the more interesting ones. Research topics in music was one that was a head scratcher. I actually scheduled a meeting with the PI because I wanted to talk with him about what that meant. And it's really kind of interesting analyzing all different aspects of music performance and music notation, different things. Genomics and genetics, again, security. And then we're doing workshops all over the place across the board with Galaxy, with Research Data Alliances, data analysis in almost every field you can imagine. So a lot of different things. Principles of cloud computing is an easy fit too, for the obvious reasons. Who's familiar with Galaxy? It's not really, oh, well, that you don't count. That's cheating. Galaxy is a little bit out of your wheelhouse. So Galaxy is a platform developed for bioinformaticians. It has a lot of different tools already built in. You bring your data, you set up your pipeline using a web interface, and you point and click and hit the go button and walk away. So Galaxy is one of our partners, and they're doing work on Jetstream in a couple different ways. So the first and easy one is they have a Galaxy image. So anybody can come in and launch a Galaxy image and use it and do whatever they need to do and have full control over it. The interesting one is that they have a virtual cluster running on Jetstream. So if you go to usegalaxy.org and you submit a job and it fits a certain profile, so they have small, medium, and large jobs. If you hit a small job, it gets processed on their local cluster, which is, I think, I don't even know how many cores, but it's not many. I think it's if you have under a dozen cores needed, it processes it right there. If you have a large job where you need hundreds to thousands of cores, it goes to Stampede 2. If you have that middle ground where you need anything from 20 cores to, call it 200 cores, they have a virtual cluster running on Jetstream that pops up as needed, so they have a head node running all the time. It feeds the job in, and Slurm does this really cool thing where it understands cloud nodes, and it sees, oh, I need this many cores, and it starts spinning up worker nodes. So it spins up as many as it needs, it feeds it out, it brings it all back and feeds it back to Use Galaxy and returns it to the user. So it's a really cool way that they're using it. And we have more people, especially more gateway users, going that same route of doing virtual clustering where they can do it on demand. They can save their allocation. They just have to have a small instance running, call it a 2-core instance running all the time. And then as they get jobs to come in, they pop up whatever they need to get the work done. So it's been an interesting model, and it's something we're kind of building on. It's a community software project. It was originally funded by an NIH grant and still funded by an NIH grant as well as several others now. But they started out at Johns Hopkins as a lab project for doing genomics work, and once they started getting their funding, they just grew and grew and grew. So it's all publicly available software. They're very active in the genomics field. It's interesting though, you can actually use Galaxy for anything. Most people do know it for genomics, but if you can wrap any tool in Python, you can plug it in and use it via their web interface. We actually have some text analysis people using Galaxy because they didn't want to write their own interface. They wanted a GUI interface that was easy to use and easy to maintain. Galaxy is. I mean, it's just an Nginx-based software package that runs on a web server. And you wrap your tool in a Python wrapper, and away it goes. So a little bit of our gateway highlights. So we talked about how gateway users are a big part of Jetstream. We currently have, I think, 25 active gateways on Jetstream, various sizes from very small to very large. We have you can kind of see the array of different things. Neuroscience Gateway is probably one of the largest ones out there right now. They are using us for some of the processing, then they're using Comet for part of the other. Sorry, just lost my place. We have several immunomics and genomics gateways. Unidata, of course, is there, one of our largest users. Cgrid is a molecular chemistry gateway. They're using both Jetstream and other Exceed resources. And then we have one that's a really interesting one, which is a GIS gateway that is being developed out of the University of Minnesota that's actually using the Esri software via a gateway to do analysis. Yeah.
I'll just add, that's the project that David Alonso is working.
Yes. And it's getting close from what I understand. I'm actually really curious to see that one. So the other part of what we do is the broadening impact. So again, I can't harp on training the next generation of researchers enough. We take that seriously and put our money where our mouth is. And for the last 3 summers, we've done a research experience for undergrads. We started with 4 students, then 6, then 7. We actually just finished our RU experience 2 weeks ago. It's been a success. We take people from every discipline and try to match them up with a mentor that's going to be able to further them in their field and solve a real problem. So it's been a really interesting experience having students we had a sociologist, which was an interesting one. We had a pure mathematician, which was also another interesting one because, again, these are not people that we typically find on HPC. We're not solving their problems has been a challenge, but it's also helped us learn about our own system and how we can embrace other audiences. So it's been a learning experience for us as much as them, but it's been very successful. We've enjoyed it. We hope to continue doing it with Jetstream as well as whatever follows on to Jetstream. Yes?
So, were there...
Oh, sorry. She asked if the students worked with the systems or if they just worked solely with researchers. A little of both. So it kind of depends on their field of study. So we did have 2 computer scientists, and so we kind of engaged them both with our HPC folks just to kind of get their feet wet. But then we also worked with the researchers in informatics areas to solve informatics problems. One of them was working on a visualization problem, which was just wild. So he got down and dirty into the realm of GPUs as graphical processors for rendering, but not rendering on screen. So that was something that was new to us on Jetstream because we're just now getting our feet wet into GPUs. We learned a lot from that as well, but it was definitely something that I think the student will be able to take away and be very valuable for the future because I think a lot of people are going to be getting into this area as well. So some usage highlights. So these are our numbers from Exceed. We had 412 Exceed projects, 71 fields of science. Our users at ebb and flow, we've high-watered at 2,500. We're kind of back up to 2,300, representing 217 institutions. So the second stat is the one where we feel like we're community building. So we went through the Exceed database, sorry Dave, behind the scenes and kind of pulled the numbers of users using Jetstream that had never used any other any other Exceed system. And our first year it was 87%. The first year we pulled that number, and we've actually seen it decline. And that's actually we take that as a success because we're helping researchers find their way into the national CI. Maybe they start out on Jetstream and either their problem outgrows it or they have a different problem that they want to scale up, and we can help them get to other HPC resources. So we consider that a success. If we can graduate somebody from a smaller resource into getting their problem solved faster and bigger, that's a good thing. 232 million CPU hours since we started keeping track in June of 2016. Again, yeah, 25 active gateways. Our education allocations and students ebbs and flows. Presently 59 education allocations. We expect to see that pick up again in the next couple weeks as we start the school year again. At any given time, we're running in that range of VMs. So our high water mark has been 1,600 active VMs, and that's active in a running state versus stop, shelves, suspended, etc. And what we like to say is the highest user satisfaction in the last Exceed survey on that. So yes, we pulled those numbers from the database. Sorry, I pick on Dave a little bit. I see Dave in the Exceed arena more than anything else. It's kind of weird to see him here. So what comes next? We completed our second year and we're into our third year with an extension presently to November of 2020. We're expecting that to go on a little further without additional grants. However, we're working presently on the follow-on to Jetstream. We're pretty optimistic about that, so we're hoping to see another 5-year grant come out of that. We're always soliciting allocation requests. We do all of our allocations via Exceed, so that process is documented on the Exceed site, and then I have a slide that has a URL where we have a walkthrough particularly for Jetstream allocations. By the way, all of these slides are available on the jetstream-cloud.org website. I put some business cards out there that have all the Jetstream sites on there, so I have our wiki, I have a website, and then our help address. There are also some Jetstream stickers out there for your laptops if you're so inclined. Sorry, quick side turn there. We're always adding useful services, so we're doing things like Heat, which is automation, so you can set things up to build automatically. Doing Magnum, which is integrated container orchestration, so the K word, Kubernetes, is a native part of Jetstream, although we have people that are using it outside of Magnum and using it on their own terms. Trove, which is doing databases as a service, Manila file systems as a service. We're always adding things to Jetstream that will hopefully help our users and help further their research. We're always doing enhancements to our systems, and we're always working with other groups to kind of enhance the audience and bring more to more people. So Hub Zero is the one that kind of comes to mind with this, where we've been working with them to give another home for the Hub Zero gateways. So it kind of gives another place for a lot of groups to work. So requesting access to Jetstream, trial allocations are available now. So one caveat about trial allocations: they are limited to 2 VMs with 2 cores. It is truly meant for you to just get your feet wet. The upside is that for students, for people that are not PI eligible, so if you are an undergrad, a grad student, it gives you a place, bless you, to try Jetstream. If you are PI eligible, which is all center staff at research institutions, faculty, I recommend getting a startup allocation because you get 50,000 core hours. You have no limitations on the size VM you can run. So you get a little more to try out with. And this webpage actually walks you through both getting an Exceed account if you don't have one, and then the steps to actually getting a startup allocation. You can also get educational allocations at any time. The restrictions there are just a little different. We require a syllabus as well as the CV that you would normally have and the abstract for why you're using it. But we also have a web page that I need to include here that walks you through that process as well. Research allocations, which get you to the larger scale allocations, so hundreds of thousands to millions of core hours, are done on a quarterly basis and are reviewed by a panel at Exceed. Those are the next submission period opens for that in September. Then the other part about that is that research allocations are what I like to call NSF light. So they're 5 to 10 pages plus a scaling doc. We have some guidance for that on our website. We actually have a Cornell virtual workshop to help walk you through that process. And the other part of it is we will help. So if you started your allocation request and you want some feedback on it, we're more than happy to review that. For better or worse, there's some gotchas that will automatically get you kicked out of the submission process, just like anything else. They're laid out on the web page, but a lot of times people just, for whatever reason, maybe you just skip over it, maybe you miss it. We kind of help you work through that and make sure that all the things you need to have are all there. So the ubiquitous help slide. The wiki is what we keep most up to date. So that is our help site. That is on the business cards that I put out there. The user guides are at the Exceed portal. They tend to clone our wiki every month or two. Exceed Knowledge Base and the Exceed Help. And then Campus Champions. I don't know if Campus Champions existed in CAR. I'm going to look at you, Dave.
We have one.
Okay. Oh, okay. Gotcha. Campus Champions typically exist to be consultants for Exceed resources and general CI infrastructure questions. They can kind of help steer you toward what is the correct resource for me to use. They also have an Exceed allocation of their own that they have discretion over. So if you want to try out Jetstream or Stampede 2 or Comet or Bridges, he can add you to that allocation and you can try it out. That's completely at their discretion. Again, we also have some Cornell virtual workshops. We have a third one that was just published that I need to add on here, but we have an intro to Jetstream which kind of walks you through using Jetstream. It walks you through the atmosphere interface, kind of gets you going as a step-by-step. For people that like videos as part of their training, we include a lot of videos to kind of show each step of the process. We also have a getting started guide on the wiki that kind of walks you through in text with images, but it kind of gives you a little more in-depth. We have an allocations virtual workshop, which I kind of alluded to a few minutes ago, where it can kind of walk you through the allocations process and help you with some of the things that are unique to Jetstream. And then the third one that's missing at the moment is a DOI workshop, which is, we've made a process with Jetstream in a partnership with IU that if you've published a data set, a paper, whatever, using Jetstream, and you want to preserve your VM for other people to try to use, you can actually submit a form, and we will take your VM and put it into our handle system where it will be preserved and other people can come download it. They can run it on VirtualBox, they can take it to AWS, whatever they want to do. But it gives you a way, one, you get a publishing link, you get a true DOI, and then other people can try it out and hopefully reproduce your science. And then some just for fun. So this is Jetstream at IU, and we have Motivair cooling doors on the back. So when everything's good, we're blue. When we are out of sync, we go red. And I usually, at this point, make a joke that our first PI, if he'd seen them red, he would have wanted them to be red all the time because of IU. I can't really make that joke anymore because we actually were asked this week for the unveiling of our next HPC system if we could turn the doors red for the ceremony. And I just laughed and laughed and laughed. Yeah, we can do it. And I told Dave, the PI, I'm like, you realize that I've made this a joke in every one of these talks for the last 3 or 4 years, and you're really asking to do it now. And he's like, yeah, I know. Life imitating something, I don't know. And then the more fun one. So our system engineer has a thermal camera, and you can actually see this end of the cluster is nice and cool. The other end, where it's all red, we're actually cooling the room on the black side of the doors. So Wrangler is another 2-part system that sits at TAC and IU, and Wrangler sits about right here, and it apparently heats us up really nicely. So we cool the room except for Wrangler's portion, which apparently we're cooling Wrangler as well. And what I like to call our NASCAR slide. So this has all the major partners and minor partners of Jetstream. It's led by Indiana University, my employer. We're partnered with TAC and University of Arizona, Johns Hopkins for Galaxy, and University of Chicago with Globus. And then these were some other folks that played roles along the way in terms of either VM development or consulting that we like to pay a little tribute to. And then the ubiquitous question slide. So I am at your disposal. What questions? Anything and everything. There is no question too small. No question too large either.
All right, questions?